Here's problem 3910. A 30-year-old woman takes a trip on a rocket, leaving her 20-year-old brother behind. She travels at a speed of 0.8 c and has gone 20 years, according to her younger brother. When she returns, how many years older or younger is she than her brother? Well, there's a couple ways to approach this problem, and one way is through time dilation. Now, we know that the major events occurring in this scenario are occurring with the woman on the rocket. She's going to have to go to a further place, and then she's going to have to turn around and come back. So everything that's important with this scenario is happening in her frame of reference. She has the proper time. And the brother who's left behind then is going to measure a dilated time. However, we cannot believe any measurements of the time taken by the woman in the rocket because her frame of reference is accelerated as she turns around. We can integrate that over a series of constant velocities, but that would be a complication that we don't need to apply here. What we can just say is that the traveler, the woman, has the proper time, and the measurement of her brother is the dilated time, which we know to be 20 years. We can calculate gamma here and get the actual proper time for the woman. So that's what we want to do. Now gamma is going to be equal to 1 over the square root of 1 minus 0.8 squared, which of course is going to be 1 over 0.36, 1 over 0.6, or 1.67. So that's our gamma, 1.67. So the proper time measured by the woman in the spacecraft is going to be 20 years divided by gamma, 20 divided by 1.67, which is 12 years. So for her, the trip there and back again took 12 years. And so the woman's age, the age of the woman, is equal to her initial age of 30 plus this 12 years that she aged while being in the ship. So she is now 42 years old. The age of her brother is his original age of 20, and then he measured that the trip took 20 years, so he is now 40 years old. So the woman is 2 years older than her brother. She used to be 10 years older, but now she's only 2 years older. That's one way to look at this problem. Another way to look at it is from the woman's perspective. As she's traveling from here to some distant place, the length is moving, the length of that trip is moving with respect to her, and hence the length of the trip is contracted. So the actual length that she goes is not the full distance of the trip, but instead the length contracted by gamma. Alright, well, what is the length contracted, the length in the rest frame, the L naught in this case? Well, the brother measured 20 years for her trip, moving at, as he saw it, 0.8 c. So he thinks in his rest frame that the length is equal to her velocity times time, which is going to be 0.8 c times 20 years, which is going to give 16 light years for the distance. She's going to measure instead L naught, 16 light years divided by gamma, 1.67. So that's going to be a distance of 9.6 light years. So her full trip is 9.6 light years, and if she's traveling at 0.8 c, then her proper time, as she sees it, is going to be the distance, 9.6 light years, divided by 0.8 times the speed of light, and that is going to be, indeed, 12 years. So again, she measures her proper time as being 12 years in terms of a length contraction problem. The rest of the problem is the same. She has an age of 42 years. Her brother is aged a dilated time, she sees it, of 20 years. So he's 40 years old, and she's 2 years older than her brother when everything is done.